All right, guys, so this is day 2 of taking the notes at home and doing the homework in class. I'm having to use a little different program today because I'm going to explain everything wasn't working, but it shouldn't matter to you guys. If you would, over here at the left side, make a little circle with a dot inside of it. That'll help me check it a little bit better. So we're talking about the effects of changing dimensions on area. This is like, so I found the area of a rectangle, but then I double one side, triple the other. What's the new area? Instead of recalculating, we can just go ahead and use some little tricks to help us out. So the first thing we're going to do is look at this rectangle. It says find the area of the rectangle below. It's got it split up, and since I have 60 degrees in the top right, I know I have 30 degrees down here at the bottom. So I have a 30, 60, 90 triangle. Means this side is x, this side is x square roots of 3, and the side they gave me, the hypotenuse, is 2x. So it's pretty easy to find the stuff we need. If 2x equals 8, then that means x equals 4, and that would mean x square roots of 3 is actually just 4 square roots of 3. So we can find the area real quick. Since it's a rectangle, we're not going to do apothem and perimeter. We're just going to do base times height. So that's 4 square roots of 3 times 4, which gives us our area of 16 square roots of 3. So 16 square roots of 3 looks like it's centimeters squared. So what we're going to do is we're going to look at 4 different examples, and we're going to change the dimensions on that rectangle and see how it affects. So when I push this button, it's all going to go away, so I hope y'all are paying attention. Let's go down to this table here. It says, what would happen if we changed one or both dimensions in this rectangle? So we're going to start with our original area. It was 16 square roots of 3 centimeters squared, okay? So it's going to tell us what to do to the width and length. We're going to calculate the new area and then compare that to the original area. So what it says is it's going to be twice as long. Well, the length was 4, so I'm going to multiply that by 2, so my new width is 8. It also says twice as long on the length. So I'm going to take my 4 square roots of 3, multiply that by 2, and get my new length is 8 square roots of 3. So I can find my new area, base times, or length times width. That's 8 times 8 square roots of 3, which gives us a new area of 64 square roots of 3. So I went through that one kind of quick. I mean, doubling things isn't very bad. And we got our new area. Now I want to compare that to our old area. So over here it says put your new area over the original area. So my new area was 64 square roots of 3, and we're going to divide that by our original, which was 16 square roots of 3. Now the square roots of 3 cancel out, so it's basically 64 divided by 16, which would be 4. Now, if you think about it, isn't 4 really 2 times 2? So if we double things, and we doubled both dimensions, it looked like our area increased by a factor of 4, which was our scale factors multiplied together. Let's see if that trend continues. Let's go to the other one. I'm still looking at 16 square roots of 3 centimeters squared. But now it says on this one, the change in width is it stays the same. So I'm going to put a 4. It's 3 times as long, though. So I have 4 square roots of 3 times 3, which is 12 square roots of 3. So I have a new length. I have a new width. I'm going to find my new area. That's 4 times 4 square roots of 3. Oops, sorry guys, messed up a little bit there. How about 4 times the actual thing we found, 12 square roots of 3. And when I multiply those together, I get 48 square roots of 3. So same as last time, I'm going to take my new area, 48 square roots of 3, and I'm going to divide it by my original area, 16 square roots of 3. So again, we can simplify here. The square roots of 3 cancel out. 48 divided by 16 ends up giving us 3, which when you think about it, isn't that the same as 1 times 3? So you might be seeing a trend here. We'll look at it more specifically in just a second. But if I had to guess, it looks like I take my original area and multiply it by the changes in dimension. Let's look at the third one. Again, 16 square roots of 3 centimeters squared. This time, the length's going to be 4 times as long. So 4 times 4 gives us our new width of 16. The next one, the length is half as long. So that's 1/2 of 4 square roots of 3 which gives us 2 square roots of 3. So let's see. Hopefully when we do this, like kind of how it was up here where I got 1 and 3 and 2 and 2, let's see if we get an answer that's really 4 1/2. So I'm going to take 16 times 2 square roots of 3, and I get 32 square roots of 3. Let's compare that to our original. Some of you can probably already see what's happening. 32 square roots of 3 divided by 16 square roots of 3. The square roots of 3 cancel, of course, and 32 divided by 16 gives us 2. And if you think about it, isn't 2 the same as 4 times 1/2? So it looks like our trend is continuing. Let's check one more. So 16 square roots of 3 centimeters squared again. I know that's a bit redundant. But now we're talking about 1/4 as long. So that's 4 times 1/4. 1/4 of 4 is 1. So there's our new width. The next one says twice as long. So that's going to be 2 times 4 square roots of 3, which gives me 8 square roots of 3. So now let's try this one out. That's 1 times 8 square roots of 3, which is 8 square roots of 3. Now that's the first time we've got one that's smaller. So let's see what happens. Our new one is 8 square roots of 3 divided by 16 square roots of 3. The square roots of 3 cancel, and I'm just going to simplify 8 over 16 to 1/2. But 1/2 is also 1/4 times 1/4 times 2. So it looks like they were pretty consistent. If you look at the numbers over here, I multiplied our original by 2 and 2. That's what we did, twice as long on both of them. Then 1 and 3, 4 1/2, and 1/4 and 2. Now let's put this into words and see if we can make some easy problems out of it. Let me scroll down to the bottom here. It says write a conjecture, or really like an educated guess. Can you make regarding the changing of dimensions in a two-dimensional figure? Now guys, this is a two-dimensional figure. It's not like a cube, it's something flat on the paper. So I'm going to say that my new, keep writing along, my new area is equal to my old area times, now this is a different little thing. I'm going to write something down here. When I put a triangle inside of words like this, it means change. So when I do this one, I'm going to take the old area times the change in width times the change in length. So if my change in width was half as much, I'd put a half in there. If my change in length was 10 times, I'd put 10 in there, and I'd multiply them by our old area. So let's look at a couple of examples. I think you'll see this is pretty easy. Let me scroll down here again. It says the area of an equilateral triangle is 36 square roots of 3 square meters. What would the new area be if its base were doubled and its height were tripled? So we're doubling and tripling. So I'm going to put over here new. This is for our new area. Then I write my old area, 36 square roots of 3. Then I put in my changes. They said that my base is going to be doubled, so that's times 2. And my height's going to be tripled, so times 3. Now I just need to do the multiplication. I have my answer. 36 times 2 times 3 gives me 216 square roots of 3. So my new area, 216 square roots of 3, and it looks like we've got meters squared. So make sure you use those right. The doubled and tripled are times 2 and times 3. Let's try another one. The area of a rhombus is 40 square inches. What would the new area be if one diagonal was halved and the other was doubled? So I'm going to underline halved and doubled. I'm going to write my new area is equal to my old area, 40, times, well, halved would be 1/2, doubled would be 2. Now you might realize that 1/2 and 2 cancel each other out. 40 times 1/2 times 2 again is 40. So my answer is 40, and it looks like inches squared. So guys, we just did an equilateral triangle and a rhombus, so this means it works on any shape. Let's look at the last one. The area of a triangle is 36 square millimeters. Suppose the height was 3 times as long and the base was 4 times as long. What would be the area of the new triangle? So guys, I think you should try this one by yourself real quick. You might pause for a second. Trying it out is really going to help. So I have my new area equals my old area times 3 for the 3 times as long times 4 for the 4 times as long. 36 times 3 times 4 is 432, and it looks like we have millimeters squared. So when you have an old area and you need a new one, just multiply it by the changes in those dimensions. Hope this works out for you. Good luck.